So, uh, Good morning to all. This is Anvesh, and I'm from AAA branch, A section. Today my topic is about renewable energy today and tomorrow. So, let's get into the topic. So first, progress in renewable energy technologies. The term renewable energy is energy derived from a broad spectrum of all sources, of all which is based on the self-renewing energy sources such as sunlight, wind, flowing water, the earth internal heat, and biomass such as energy crops, agriculture, and industrial waste and municipal waste. These sources can be used to produce electricity for all economic sectors, fuels for transportations, and heat for building and industrial process. Renewable energy contributes as much today to US energy production as nuclear 10%. Each renewable energy technology is in a different stage of development and commercialization. Some technologies are renewable energy technologies in different stages of renewable energy consumed in United States in 1998. Hydropower comprised 55% biomass including municipal solid waste, 38% geothermal and 5% solar and 1% and wind 0.5%. Detailed information on over 7,000 facilities that generate US grid connections for electricity from renewable resources is available electronically. Renewable energy technologies offer import benefits compared to those of conventional energy sources. Renewable energy sources worldwide thousand times an energy reaches the surface of the earth from sun, then it is a fossil fuel consumed. The renewable energy resources are not uniformly disturbed through. However, every region has some renewable energy resources. So most of the renewable energy systems are modular, allowing flexibilities in matching load growth. Today, market for renewable energy technologies range from specialized market to centralized energy production. For the centralized energy production, renewable energy systems are relatively capital intensive compared to the competing convention technologies such as natural gas combined cycle power plants. However, after the initial investment has been made, the economic of renewable energy technologies improve in comparison with conventional technologies because operating and maintenance costs are low compared with those incurred using conventional fuels. This is especially true in all regions of the world when where world fuel prices are relatively high and will be especially true in future as fuel prices increase. For both solar and the wind system, the fuel cost is not only constant, it is zero. For life of system, renewable energy system generates little if any waste or pollutants that contributes to acid rains, urban smoke, and health problems, and not required environmental cleanup costs or waste disposal fee. Potential global climate change caused by excess carbon dioxide and other gases in the contribute other gases in the atmosphere is the latest environmental concern. System using solar, wind and geothermal sources do not contribute any carbon dioxide to the atmosphere. So first the photovoltaic energy. So photovoltaic device use semiconductors material such as silicon to convert sunlight to electricity, then contain no moving parts and produce no emission while in operation. Extremely modular photovoltaic device can be used in small cell panels and array. Photovoltaic system required little servicing or maintenance and having typical lifetime of about 20 years. Through the National Center for Photovoltaic at NREL, researchers in government, universities, and industries are working together to lower production cost. Their efforts are focused on developing more efficient semiconductor materials and device designs, while expanding production capacity, increases protection rates, and improve product quality. Capital loss of capital cost for photovoltaic panels have decreased from have decreased from more than $50 dollar 50 in the earlier 180 1980 to uh, dollar per weight today. Energy costs that have been declined from about 0.90 kilowatt in 1980 to about 0.20 kilowatt. Although this is still higher than the cost of conventional baseload electricity. Commercially, homes are uh, recreational vehicles, and in developing countries for remote power for village homes. A new type of photovoltaic is now emerging, with the first commercial product now in development. Conventional solar photovoltaic are, as discussed above, use the energy of light to generate electricity. Thermovoltaics uses the energy of heat or infrared radiation to generate electricity, with the advantage that a generator can operate at night or when the sky is overcast, eliminating the need of batteries too. Though it does need a fuel such as natural gas to provide the heat, using semiconductors for conversion rather than conventional diesel generators result in high fuel to electricity conversion efficiencies, modulatory, minimal pollutants, quiet operation, and high reliability. Applications under development include small power units to supply electricity in remote areas or for military troops. A US company is also planning to market a thermal photovoltaic generator to run electric equipment on sailboats. So now basically the wind energy system convert the kinetic energy of the wind into the other forms of energy such as electricity. All the wind design can be quite complex. Most commercially available in the wind turbines and use horizontal axis configuration with the two or three blades, a derived train including a gearbox and generator and a turbine to support the rotor. A typical size of one wind turbine range from 200 to 750 kilowatt, with the electricity produced within a specific range of a wind speed. Rapid progress in the technologies has been reduced costs until they have competitive with those conventional powers. Capital costs have been declined from about $2.2 watt in earlier 1980 to less than the dollar 1 watt today. Energy costs have been decreased from about 0.40 kilowatt to as low as 0.04 to 0.06 kilowatt today in areas within good wind resources. In the United States, cooperative research between DOE and manufacturing companies in aim at increase the aerodynamics efficiency and structural strength of wind turbine blades, developing variable speed generators and electronic power controllers, and using taller towers that allows accessibility winds found at the greater heights. So more than 3,900 milliwatts of additional wind capacity, totaling dollars 3.9 billion in sales, was installed worldwide in 2000. This reflects 35% annual growth rate in total installation in 2000. International markets have been growing much more rapidly than US markets. Installed capacity in Europe dominated by Germany and Denmark has surpassed installation in the United States, and it's rapidly increasing. The United States installed only 30 milliwatt in 2000. China already has more than 1 lakh wind turbines generating electricity and pumping water in rural areas far from existing power lines. According to the American Wind Energy Association, as much as 13,500 additional megawatts of wind capacity may be installed worldwide in the next decades. The US wind industries is thinly capitalized, except for the acquisition of one major wind company by Anon. There has been two bankrupt filling recently. Europe has two as many wind manufacturing and developing companies. Some have already established. North American manufacturing facilities are uh, penetrating the US markets. So next is the biopower. The biomass power plants generate electricity from biomass resources, uh, ranging from agriculture and forest product reduces to crop grown specifically for energy production. Direct combustion system burn biomass in a boiler to the produce steam that is expanded through a turbine or generated to produce power. Co-firing substitutes biomass for coal in existing coal-fired boilers. Gasification converts biomass to a fuel gas, biomass to a fuel gas that can be substituted for the natural gas in combustion turbines. Today, U.S. biopower industries, approximately 1,000 plants consist of direct combustion plants with a small amount of coffee green. Plant size average to 20 milliwatt with efficiencies about 20%. Electricity cost of dollars 0.08 to 0.12 kilowatt. Grid connection capacity has increased from less than 200 million in 1978 to more than 7,500 milliwatt in 1998. About 70% of this in this forest products and sugarcane industries. Municipally solid waste plants provided additional capacity of 3,300 megawatts. So my biopower capacity is rest of the world is about 2,000 to 25,000 megawatts, and international markets are strong with at least six major multinational companies actively involved in this industries. Next, geothermal energy. So the geothermal resources include dry steam, hot water, and hot dry rock, magma, and ambient ground heat. Steam and water resources have been developed commercially for power generation, and ambient ground heat uh, is used commercially in geothermal heat pumps. Methods of tapping the other resources are being stupid. Research centers on lowering cost, improving methods for finding the characterizing reservoirs and tapping borders. Centers on lower cost, improving methods for finding characterizing tapping borders resources. Uh, the GSS steam power plant in California is the oldest and largest geothermal power plant in the world with a capacity of 2,000 megawatts. Hot water plants have been developed more recently and are now major source of geothermal in the world. Total US capacity is about 2,800 megawatt, enough electricity for 3 million people at a cost of 0.05 to 0.08. Hot water from geothermal resources is also used directly to provide heat from industrial process, dry crops, or heat buildings for a total US capacity of about 500 thermal megawatt. So tomorrow impact on renewable energy on the world. From dawn of human civilization to about 100 years ago, the source of energy used making very predominantly human and animal muscle and wood, with lesser amount of solar, wind, hydro, and geothermal. With the discovery of oil, development of natural gases fields, and widespread distribution of electricity from coal powdered central power plants, fossil fuels become the predominant sources of energy in the United States and the world. Is there another major transition ahead for energy resources? Can the renewable energy resources that sustain early civilization by harness with enough efficiency and availability and at a cost to meet a significant portion of much higher energy need to today's society? Although always risk in predictions, the convergence of some of the today's trend suggestion possibilities. In summary, today's converging trend relatable to renewable energy relevant significant scientific discoveries and engineering progresses. So lastly, the environment. The energy production and use already does more environmental damage on the world that any other economic activity. Although the United States had has made sustainable progress in improving the environment since the mid 90s 1970s. The power plants are still responsible for 72% of sulfur dioxide emission, 33% of nitrogen oxide emission, and the public health the implication of energy related pollution present serious challenge. Recent studies link health problems with a particular particulate matter, sulfur dioxide, nitrogen oxide, and ozone carbon monoxide. And with respect of a global warming, the burning of fossil fuels contributes three-fourths of carbon dioxide emission. Uh, so the 1224 proceedings of IEEE volume on it in United States today, the meeting the rapidly growth or demand for the energy while also maintaining a clean global environment required clean energy to power the economy. So thank you. This is about my topic. Uh, So I want to give a conclusion that within border of varieties of technologies that constitute renewable energy, some are already making large inroads in the marketplace. Other technologies, perhaps, those most beneficial to a sustainable future from commercialization, most however are progressing more quickly than ever. There are no technical stumbling blocks for renewable energy. Renewable energy is a force today and will be a major force in American future. The only question is when. The answer will be depend only on the will of American people of for clean energy or the next majority political disturbed in Middle East. Thank you.